Assalamualaikum. My name is Nur Hashimah binti Shah. My matrix number CD21087. Today I would like to present introduction. Okay. Counter gravity pumps supply liquid upward acting against gravity in water supply plants, irrigation industry and local river water extraction. Centrifugal pump preferred due to high efficiency and simple construction. A fresh graduate must design a centrifugal pump for extracting river water. Required flow rate 0.0005 until to 0.002 meter cube per second. Pump head 10 to 100 meter. Design must meet project constraints on blade angle, width, and radius. Student applies centrifugal pump theory and dimensional analysis to create efficient design, enhancing critical thinking, fluid dynamic application, and readiness for real-world engineering problems. Okay, for objective of study, first to design a centrifugal pump that extract river water within the given head range 10 to 100 meter and flow rates 0.0005 to 0.002 meter cube per second. Second, to determine appropriate design characteristics that follow the specified constraints such as blades angle, width, and radius. Third, to apply centrifugal pump theory and basic mechanics concept to conduct a dimensional and performance analysis of the suggested pump design. Okay, for scope of study, design a centrifugal pump with a total dynamic head of 10 to 100 meters and water flow rates between 0.0005 and 0.002 meters cube per second. Then, apply dimensional analysis and centrifugal pump theory to inform the design and performance assessment. Third, complete with the design restrictions such as the blade inlet and outlet angles, the breadth of blade and the inlet and outlet, and impeller radius. Then, and last, to prepare student ready for real-world fluid machinery design issues, simulates, and engineering activity. Thank you.
Assalamualaikum. My name is Siti Farid matrix number CD208. So today I will is the part of design specification. So here we have the parameters and 5 of type arm. So we start with the parameter. So the parameter we have the flow rate, and then we have the total head, also inlet blade angle, and then outlet blade angle, and then inlet flow angle, and then inlet width, and then outlet width, and then inlet radius, outlet radius, and then efficiency. So for the value of each pump is, the first pump have 15, and then the second is 75, and 75, and then 50, and then 90, and then 25, and then 50, and 15, and then 40, and then 15, also 70. For pump 2, we have the value of 18, and 90, and then 80, and then 55, and then 90, and then 30, also 20, and then 45, and 18, and then 75. For pump 3, we have 1, and then 60, and then 70, and then 45, and then 90, and then 50, and then 10, and then have 30, also 100, and then 65. So the pump 4 is 2, and then 100, and then 80, and then 60, and 35, and then 30, 50, and 280. So the last pump is 1, and then 50, and then 60, and 40, and then 10, and then 50, 20, 80, and then 70. That's all for me. Thank you.
Assalamualaikum, my name is Nurana binti Didi with metric number AD210091. For the part design analysis, these are the calculations and the formulas that we are using. First, we find the theoretical head, and then we find the pumping power, and then moving on to the theoretical flow rate using all the information before, and then we find the pressure increase and the maximum theoretical flow rate. By using all the values that are chosen, we are designing for 5 design of pump. These are the summary of table of the properties that we are choosing. So these are the summary of all the calculations for theoretical head, angular velocity, theoretical flow rate, pumping power, pressure increase, and maximum theoretical flow rate. Moving on to calculation for dimensionless coefficient. These are the formulas that we are using for our dimensionless coefficient, flow coefficient, power coefficient, and head rise coefficient. So this is the summary table of the dimensionless coefficient for all of the 5 designs, where here is the flow coefficient of the design 1 until 5, power coefficient, and head rise coefficient. These are based on the values that has been calculated before using the properties of the centrifugal pump.
Assalamualaikum. My name is Hazina Jaha binti Suhaimi and my metric number CD210189. So for the discussion, among the 5 pump design that we analyzed, design 3 stood out as the most balanced in terms of performance and efficiency. Each design was evaluated based on key parameters including head, flow rate, power consumption, and efficiency. Design 3 produced a head of 92.31 meters, which fall well within the required range. It also required a moderate power input of 46.66 kW, making it practical for real use. When we look at the dimensionless coefficient, we found that the value CQ is 0.00039 and CH, which is 0.147, and CP 0.0046. All these values fall within typical efficient operating range. This tells us that design 3 perform close to the best efficiency point or BEP, which is where pump operate most effectively. Based on all of this, we can confidently say that design 3 is the best overall choice for this application. For the conclusion, in this project, we study 5 centrifugal pumps designed using theoretical calculation and dimensional analysis. Each design was checked based on the head, flow rate, power use, and efficiency. After comparing all the results, design 3 is the best choice because it has a balanced performance, used reasonable power, and showed good results in the dimension analysis. This project showed that it's important to choose a pump that meets all the technical needs but also save energy and work efficiently. That's all from our group. Thank you.